All right, so go ahead and work on this one with me here. So with number 3, the first thing you'd want to notice, if we're asked to factor this, did you notice that there's no GCF? There's no number or variable in common amongst all 3 terms. And so we're kind of stuck with that lead coefficient, sometimes referred to as the A value, is not going to be 1. So whenever the A value is not 1, here are the steps, and these are common steps amongst both methods. So the first thing we want to do is we want to find AC. I don't know if you guys remember what that is. In this case, do you guys know what AC would be? 18. It would be 18. That's right. It's 6 times 3, which is 18. And then once we get that 18, we either use the column method or the diamond method to work with that. So I'm going to go ahead and do the diamond method here. I'll put the 18 here. And what goes in the bottom of the diamond? Negative 11, that's right. Okay, so now we ask ourselves, which numbers multiply to be 18 and add up to be negative 11? That's right. Negative 9 and negative 2. So whether you're using the split the b method or whether you are using the bottoms up method, these first couple of steps are going to be the same. So here is split the b. Here's what we do. I'm going to take this original trinomial and I'm going to rewrite it as 6a squared minus 9a minus 2a plus 3. So I'm going to take that negative 11a and just split it out as negative 9a minus 2a, again using the numbers that I got from the diamond. Once I've done that, I'm going to group the first two, and I'm going to group the second two also. Once I've done that, I'm going to ask myself, is there anything in common in that first parentheses? 3a. Bless you. Yep, I agree. 3a. And when you factor out the 3a, what's left over? 2a minus 3. Good. Now we compare that to the second binomial. The second binomial doesn't have a real obvious GCF, but yeah, did you notice how that's almost the exact same thing as the leftovers on our first term? So we're going to factor out that negative 1. That'll make a big difference here. So negative 1 gets factored out. That'll turn it into positive 2a minus 3. And now notice that both terms have 2a minus 3 in common. Let me finish this real quick and I'll come back to your question. So I could write this now factored as 2a minus 3 in parentheses times 3a minus 1. Okay, your question. Go ahead.
So I've noticed like one of the terms is always the same, like the in parentheses term. Like, why is that and why is that important?
Well, so it's been carefully designed to work. And the reason why it's important is so that it will work, right? So if I designed a bad question, then, you know, you could conceivably get to a point there, kind of the spot you're talking about, where you're like, well, they don't look the same at all. So in a case like that, either you made a mistake or I made a bad question. So it should work. Okay. Yeah, if it's factorable, it should work. Avery.
So for a quiz, are we going to have to know like this method and the bottom?
Nope. Just pick one that works best for you. Yep, definitely. Okay, so that's split the b, and let's do bottoms up over here. So bottoms up for this step here and this step here are exactly the same. So I'm just going to jump off from that point. So here's how you would write this. We would go a minus 9, a minus 2. Again, just using these two numbers that I got from my diamond. Now at this point I got to recognize that my lead coefficient was not 1, so that's really not the right answer. What I need to do then is take that lead coefficient, which was 6, and put it under the 9 and under the 2. Once I've done that, I want to take those fractions that I have now and reduce them to lowest possible terms. So does that 9/6 reduce? Something goes into 9 and 6. 3. So it would reduce down to what? 3 over 2. And then how about 2/6 is really a minus 1/3. So after you've reduced those fractions to their lowest terms, if you still have fractions over there, go bottoms up. And by bottoms up, I mean this. The 2 gets to come up front. The 3 gets to come up front. So the bottom of the fraction comes up. So bottoms up would give us 2a minus 3, 3a minus 1, and you're done. You can see it's the same answer. So to Avery's point earlier, I really don't care at all which one you pick to use. There are other methods even. There's one called the Berry method. There's another one. I'm forgetting the name of it. There's at least 2 other methods that are used pretty widespread. These are 2, I think, very good ones. You pick what works best for you. You guys have any questions on either one of those? Okay. Okay, fair enough. Let me show you one more, and then we'll get practicing. Yeah, we'll have time to practice the board. Let me show you one other version here of how this could go. And it's right here. So sometimes you'll have a GCF you got to deal with first. So let's take a look at number 4. We'll save number 5 for tomorrow. Okay, so tell me what you see. You guys are starting to get pretty experienced with these. What do you see going on with number 4? What do your instincts tell you?
Run, for sure.
You have an X in all of them.
There's an X in all of them. What else do you see?
5 and 10.
Jake, go ahead.
They're not in descending order.
That's exactly right. Yeah, Danny said the same thing. The order's all messed up, isn't it? So we definitely are going to want to get an X out. I think descending order is definitely something we want to do. So I'm going to write it, like you said, in descending order. So that would be negative 10 x to the third minus 23x squared plus 5x. This is a little more familiar territory. And I think at this point, let's talk about what Amelia said. She said there's an x in common. Is there anything else in common that we could factor out? What do you see, Jake? Besides the x.
Do you factor a negative?
I personally would factor out a negative.
Okay.
Negative 1x. Why would I go to that trouble?
Because you want your first one to be positive.
Yeah, if my a coefficient is positive, I think that will make life a little bit easier. So I'm going to factor out negative 1x or just negative x. Let's think about what that would leave me with. What would my first term then be? Yeah, positive 10x squared. How about my second term?
Plus 23.
Very good. The last term? Nice job. Okay. So far so good. We factored out that negative x, but now we got that trinomial we need to tackle. And of course the a value, the lead coefficient, is 10. It's not 1. So what's that key number that we got to consider?
Negative 50.
AC, right?
Yeah.
Yeah, so a times c is 10 times negative 5, which, Hunter, you identified there as negative 50. That's right.
Then you have to
Do the diamond.
23.
So negative 5, or negative 50, and positive 23. What numbers multiply to be negative 50 but add up to be positive 23?
Or negative 3 and or negative 2 and negative 20 or and 25.
Negative 2 and 25?
Yeah.
Yeah, I agree. Negative 2 and 25 are the numbers that work. So can I ask your opinion now? What have you chosen? Have you chosen bottoms up? Or have you chosen split the B? Raise your hand right now for split the B. I just want to get a sense of where we're at. Interesting. This is going to be almost exactly 50% because is everybody else bottoms up? Oh, it's a little more split the B. It's maybe like a 7-3 type of a margin. I'm going to go with the minority on this one. I'm going to go bottoms up. You guys can split the B if you want. So if I were going to do bottoms up, here's what I would do. I would take these numbers and I would write it as x minus 2, x plus 25, and I have to acknowledge that my lead coefficient was not 1, it was 10. And so I'm going to divide those two numbers by 10. After I've done that, I need to reduce to lowest terms. This would give me x minus 1/5. And this would be x plus 5 halves. At this point, because both of those are still fractions, I need to go bottoms up. So this would give me 5x minus 1 times 2x plus 5. Those of you that did the split the b, feel free to compare. Did you guys get the same thing? Yeah, so both methods work great. I'll just kind of mix it up. We'll do kind of both. Sam, you're giving me the frown.
Yeah.
What's up?
Can you do like this? The
All right. Happy to do it. Happy to do it. Okay, so I'm going to erase this. Here is split the b. Here, so if I'm going to do that, it'll look a little different, but the start is the same. So it would look like this. Oh, you know, I forgot my negative x on that last one.
Okay, yeah, that's what I was.
I totally spaced that out. I'll fix that on this one. So just dealing with the 10x squared plus 23x minus 5. Splitting the b, I'd get 10x squared minus 2x plus 25x minus 5. Again, acknowledging that that negative x really is still there. I would group my first two, and I would group my second two. Sam, what comes out, what factors out of the first two? What's that common, the greatest common factor?
X and -2.
I would pull out just a 2.
Or just a 2.
I'd get the 2x out. So that would leave me with 5x minus 1, right? What's the GCF on the second pair?
It's 5.
Leftovers would be 5x minus 1.
Okay.
And then,
Like the original, like, problem or whatever, I didn't do it the 10x squared. That's what I was messed up.
okay.
I have-
So then this would be your complete answer right here. Like I said in that previous solution, I neglected to put the negative x there, but the negative x really is still there. I would just pair that up with what I got from the trinomial and I'm good. Any other questions?
Okay, where did you get the negative X?
So that came from the very start. Remember at the very beginning we factored out the negative x?
Yeah.
And then all this other work we did was just to factor this. So what I forgot at the start was that negative x was there the whole time. I just didn't write it the whole time. I just forgot to include it on the very end. Yeah. Okay, hey, let's do this. This will give everybody a chance to do a couple of them. Let's go grab little whiteboards and markers, and let's see how you do
Be a big little whiteboard.
with these.
Big little whiteboard.